topic are structure and physical properties of this functional group carboxylic acid. So we want to discuss the structure and also the physical properties of carboxylic acid. Okay, so this is we know that this is the structure of the carboxylic acid, okay, which is the geometrical of carboxylic acid are planar, okay, because of this shape. So first we want to learn the physical properties of carboxylic acid is about boiling point of aliphatic carboxylic acid. So this one for aliphatic carboxylic acid. Okay, so for aliphatic acid from carbon 1 until 10 carbons, so the state of this acid are liquids form, because from this liquid state the boiling point increase with the increasing of molecular mass. So means that the increasing of the molecular mass or molecular weight of the aliphatic acid, so the boiling point will come increase. So carboxylic acid have a higher melting and also boiling point compared to the alkene, similar or molecular mass. So reason here, because of carboxylic acid can form hydrogen bond to one another in the solid and also in liquid. So the main reason is hydrogen bonds, because for carboxylic acid the functional group is C double bond OH. Okay, so here some of elaboration about the boiling point of carboxylic acid. Okay, as you can see here, carboxylic acid is slightly higher compared to the alcohol and also ketone and aldehyde. Why? Because the reason this carboxylic acid can form the stronger hydrogen bond. So this is the main reason why the carboxylic acid is the boiling point is slightly higher compared to the rest, because of this carboxylic acid can form the stronger hydrogen bond compared to alcohol and also ketone and aldehyde. So because of this functional group C double bond O in the carboxylic acid, which is the electron-withdrawing group, so will cause the hydroxide group in carboxylic acid is to be more polarized compared to the hydroxide group in alcohol. Okay, now there are two compounds. First compound is carboxylic acid and second is alcohol. So both of these compound attached with the hydroxyl group, but for hydroxyl group on the carboxylic acid is slightly in condition of electron withdrawing group, and so it's become more polarized compared to hydroxyl. So we can look here, so density of positive charge, okay, towards to the negative charge and towards to the carbonyl, which is containing C double bond O. So this electron withdrawing become more polarized compared to this one structure only containing of hydroxyl group. Okay, so liquid and gas state in non-polar solvent carboxylic acid is exist in dimers. Okay, reason in dimers because this carboxylic acid molecule can form hydrogen bond with another carboxylic acid molecule. Okay, because of the carboxylic acid can form hydrogen bonding, so the structure is become dimers. So dimers also increase the van der Waals dispersion forces, means that the attraction van der Waals between of this structure is very stronger, because of the carboxylic acid structure can form the dimers from the hydrogen bonding. So it will become slightly stronger compared to the compound of alcohol. So next is the solubility of aliphatic carboxylic acid. So we know that carboxylic acid is a fairly low relative molecular mass and completely miscible in water, only for 1 until 4 carbon. So reason why, because of carboxylic group is able to form hydrogen bond with water molecule. So it is easy to miscible in water. So solubility of carboxylic acid in water will decrease as the relative molecular mass increase. So means that the bigger structure of carboxylic acid, so the physical property of on solubility will become weak. So here is example propanoic acid. We know that this is a simple of the carboxylic acid containing 3 carbon. It's very soluble in water. Okay, compared to the pentanoic acid, okay, or compared to the hexanoic, decanoic, octanoic. So this carboxylic acid, the molecular mass become bigger. So it's difficult to this compound immiscible in water. So here is the solubility of carboxylic acid in non-polar solvent, so such as hexane. So increasing as the carbon chain, so it gets longer. Okay, so here is because of the hydrogen bond. So the simple structure of carboxylic acid, so easy this compound to dissolve in water compared to the larger structure of carboxylic acid due to the bulky structure of this compound. So it's difficult to miscible in water. So next is acidity of carboxylic acid. Okay, so there are several of the condition for the acidity of carboxylic acid. First, we want to compare with alcohol and phenol. Okay, carboxylic acid is slightly more acidic because of this functional group. They can dissolve in water to give hydronium ion. Okay, so this carboxylic acid can dissolve in water to form or to dissociate RCOO minus and H3O plus. Because of this structure, functional group carboxylic acid is much stronger compared to alcohol and phenol. So reason first, because negative inductive effect on the carbonyl group in carboxylic acid, and number 2, because of the resonant effect on the carbonyl group. Okay, so means of resonant effect is acidity of carboxylic acid depends on the stability of this product of the carboxylic acid react in water. So this product, because of this product, so the acidity of the carboxylic acid is changes. Okay, so number 2, strong negative inductive effect of the carbonyl oxygen. Okay, we know that in the C double bond OOH containing of carbonyl group, so we want to look the negative, we want to look the inductive effect. So what is the inductive effect? The shift in electron density from one atom to another atom form a polar bond. So means of polar bond is electronegativity. So as you can see here, the arrow, okay, of the inductive effect. So this carbon is high electropositivity, and then we draw with the electronegativity, which is a halide group for 6, 7. Then arrow in the representation inductive effect shows that first, carbon atom repels electron, and number 2, the chlorine atom will attract electron because of higher electronegativity. As you can see, this chlorine, we know that electronegativity is very higher, so this chlorine, the charge is negative. Okay, so this atom chlorine will attract the electron because of the higher electronegativity or higher of electron charge. So C double bond O group is electronegative and act as a powerful electron-withdrawing atom. So you must know these facts to do a next mechanism of the carboxylic acid and its derivative. Okay, we want you all know the C double bond O group is electronegativity and is a very strong electron withdrawing atom. So because of withdrawing electron away from the carboxylic acid, so weakens the OH bond. So the carbonyl group can lose a proton readily. So here is a structure for carboxylic acid. As you can see, hydrogen, okay, towards to the O, because O is more electronegativity. Okay, polarized to the C, which is more electropositivity, and towards to the O because of carbonyl. So this oxygen is more electronegativity compared to this one, alcohol. This structure is less polarized compared to this one. So number 3, about resonance effect of the carbonyl group. Okay, we know that this carbonyl group, which is carboxylic acid, react with the water because of the physical properties of carboxylic acid can immerse in water, so react to form the carboxylate anion. So this one is a resonant hybrid of two resonance structure for carboxylic acid. Okay, so this O minus electron will move to this one and move to another O, which is attached to the C. So this one is resonant. So two structure actually are same. So here is the reason, because of negative charge is delocalized over two carbon oxygen bonds. So delocalization or resonance stability, the carboxylate anion, and this carboxylate anion has less tendency to accept hydronium ion, and equilibrium turns to the right. Okay, delocalization of electron in carboxylic acid, okay, anion promotes release of proton and makes the carboxylic acid is stronger acid compared to the alcohol. Okay, the main reason, because of a negative charge is delocalized over two carbon oxygen bond. So that's why it form a resonance for carboxylate anion. So why carboxylic acid is more acidic compared to phenol? So reason, because of carboxylic acid can dissociate to form carboxylate ion, which is more stable compared to phenoxide ion. Okay, so why the carboxylate ion is more stable? First, because of electron in carboxylate ion distributed over two oxygen atoms. Number 2, because of delocalized onto more electronegative oxygen atom. Okay, so phenoxide ion is less stable due to the electron delocalized on the C and O atoms, and the negative charge on the phenoxide ion is delocalized onto carbon atom, which is less electronegativity compared to the oxygen. So as you can see here, phenoxide ion means that this O attached to this aromatic. Okay, so electron are delocalized on the C and O atom. Okay, and then this electron become delocalized in the aromatic. So that's why phenoxide ion is slightly less stable compared to the this one, carboxylic acid, aliphatic carboxylic acid, which is after dissociate become carboxylate ion is more stable compared to phenoxide. Because of phenoxide, this electron delocalized between CO, and at the same time this electron delocalized in the aromatic, so become more resonant, so the structure for phenoxide ion is less stable. So number 2 is the effect of the substituent. Okay, first, electron-withdrawing group increase the acidity. Okay, we know that carboxylate anion relative to undissociated carboxylic acid, so shift the equilibrium to the right and increase the acidity. Okay, so here is the factors stabilize the carboxylate anion will result decreased acidity. So here is the explanation. Because of the electron withdrawing atom, okay, means that because of halogen atoms, or electron withdrawing group such as is nitro, so the carboxylic acid will become withdraw electron density from carboxylate anion and delocalize the negative charge, so the carboxylate anion is stabilized and more acidity. Okay, when the carboxylate anion is more stable, so the acidity become increase. Okay, look at this table. Okay, see double bond OOH, okay, attached to the R, so pKa is around 4. Okay, once this carboxylic acid attached to the halogen, okay, halogen, so this one halogen for electron withdrawing atoms. Okay, okay, this one is atom of halogen, and then this one is electron withdrawing group NO2, so the acidity is become increase because of fluorine more electronegative compared to the chlorine, so it's slightly fluorine is slightly stronger electron withdrawing compared to the chlorine, compared to the compared to the bromine and also iodo. Okay, if this halogen compare with the group of nitro, so the group nitro which is this carboxylic acid attached with nitro is more stable, so the acidity is slightly very strong and the pKa value is lower. So next, the number of halogen attached to the carboxylic acid. So acidity will increase when the number of halogen atom increase attached on this carboxylic acid. So means that the more halogen attached to the carboxylic acid, so the acidity become more acidity. So here is effect the position of halogen on the acidity on the carboxylic acid. Okay, we can look here the table. As you can see from this table, it shows that the position of chlorine at alpha carbon, okay, compared to the gamma carbon, the position for gamma carbon, which is chlorine attached on gamma carbon, is slightly decrease the acidity of the carboxylic acid, which is we need the nearest of the halogen attached on the carboxylic acid, so the base of acidity strength become stronger. So here is aromatic nucleus, okay, electron withdrawing group and possess negative inductive effect. Benzoic acid is a stronger acid compared to the ethanoic acid. Okay, as you can see here, stronger acid than the corresponding saturated acid. Okay, the stronger acid. This one is aliphatic. This one is saturated, this one is unsaturated. So unsaturated is much stable compared to saturated. So acidity for alkene is slightly stronger, slightly good compared to the aliphatic saturated. Next is electron donating group. Okay, this one is electron donating group. We can see here increase in charge density, so the proton more difficult to lose. So presence of electron donating group decrease the strength of acid. Okay, means that once carboxylic acid attached to the electron donating group, so the acidity become decreased. So here is the effect electron donating strength of acidity. Okay, the more of the electron donating attached to this carboxylic acid, so the acidity become weaker. So here is the trend acidity substituted benzoic acid. Okay, so methoxide substituent alkoxide electron donating, and it will decrease the acid strength, while nitro is withdrawing, so increase the acid strength. Okay, to summarize the trend of the acidity, okay, where once the electron withdrawing attach on this aromatic, so the acidity become stronger and increase compared to the attached with the donating.